how efficient is your code? Is the change you just made going to improve your application or not? And how do you know? How important was that change? These questions cannot be answered without benchmarking. In this lesson, we're going to look at how to use benchmark.net to evaluate code in order to identify how efficient it is and how efficient it is compared to a changed version of that same code. Now, this is the first video you watched of mine. My name is Tim Corey, and it's my goal to make learning C# easier. I provide videos twice a week here on YouTube to help you grow as a developer. On Mondays, we talk about in-depth code stuff. And on Thursdays, we get into a podcast series called Dev Questions, where I answer your questions around the programming realm, not necessarily specifically on specific code bits. All right, so check out what I have to offer. I also have training on IamTimCorey.com. Those are full courses that are at a very high level, built to provide you with real world training that gets you ready to go right away. Now, in this video, as with most of my videos, I'm going to create some source code. If you would like a copy of the source code, go use a link in the description to get that code. All right, let's go over to Visual Studio. I'm using 2019, the latest or almost latest version. I am due for an upgrade to 16.10, currently I'm on 16.9, but the changes are minor enough that it shouldn't cause any problems, and I didn't want to upgrade right before I recorded a video. So let's go down here to create a new project. We're going to say a console application. We don't need to have anything complicated here. I want to get as much stuff out of the way. And in fact, the console application is going to make sure that we have very little running besides our test code. Think of benchmarking kind of like unit testing, in the fact that you want to strip everything else away. You don't want to have a lot of complex interactions if you don't have to, if that's not what you're testing. Now, we're not going to get into more complicated testing, like maybe testing an interaction that includes a database or an API, something like that. That would be a little more complicated, but still something you'd probably do in a console. You'll probably be testing against a DLL or something else like that. And so that's where you're going to bring that into your console application. All right, so let's call this our benchmark. Let's call it benchmarker. And then we'll call it benchmarker app. And we'll put in samples and hit next. We're going to use .NET 5, which is the current version as of the recording of this video. And this will allow us to run C# for Linux, Mac OS, and Windows. So this is the console app. Hopefully you're familiar with the console app. If not, maybe this video is a little too advanced for you. You might want to go back and watch other videos introducing the console and how it works. Now the first step here, we're going to get rid of the console write line in here and clean this up a little bit. And then we're going to right click on dependencies and we're going to manage Nuget packages. And in here, we're going to go to browse. We're going to search for benchmark.net. Spell it all out, benchmark.net. And there we go. We have benchmark.net. It's got 8.44 million downloads as of the recording of this video. The latest stable version is 0.13.1. This is a newer product they're still working on, but at the same time, it is working. It does work as is, and it's not something where it's a pre-production version you can't use. You can definitely use this for benchmarking your stuff. So go ahead and hit install, just the main version. Hit OK, and I accept. And now in here, what we can do is whoops. I said Control S there, and it popped up a dialog box. All right, I want to create a new class. Now, normally I'd create a new class by right-clicking on the project and saying Add New Class. But I'm going to create it right here so I can see both at the same time. We're going to create a very, very simple benchmark for you to see, and then I'll move the class over. So let's create a public class. Let's just call it Demo. Use the Shift Enter to get my curly braces. That's a newer feature in .NET. Also, notice that I'll have some, they're not showing up right now. I don't have any, let's bring that back for a minute. like so. If you see this value pop up, that's another tools options setting. That's not something that's a plugin or something else. I get asked that question a lot. That's a newer version of Visual Studio option. I believe it came in 16.9, and you can enable it. So I do have a video talking about that. If you need a link for that, let me know down in the comments and I'll link to it. Okay, so inside of the demo class, actually above the demo class, we're gonna put in square brackets, we're gonna say Memory Diagnoser and do control dot on that to add the using for benchmark.net.attributes. So that adds that using statement up here. And what this will do is it's going to add a diagnoser. So built in is already a diagnoser. We're going to add a second one, which is the memory diagnoser. I'll show you the difference with this on and off. But what this does is it allows us to see how much memory is going to be used. In fact, let's turn it off for right now. Now you've got that using statement in place. I'll turn it off at first, and then we'll add it so you can see the additive difference. Now, down here, we're going to create a method, public string. We're going to say get full string, and we'll say normally. And the reason I say normally is because we're going to modify this in a little bit. And so in this method, what we're going to say is string output, and then let's just say string output equals empty string. And then we're going to say for loop, we'll say I is less than 100. And then we're going to say output plus equals I. So this will do is it will say the output when it finally comes out will be 0, 1, 2, 3, 4, 5, 6, and it'll just count up, but all in one lumped together string. All right. So is this an efficient and cool method? No, it's not, but it's going to give us a good starting point to show off the benchmark class. So we're going to return output. That returns the full string. All right. So this is the method we want to benchmark. To do that, we simply say benchmark. Done. We have now marked this as ready to be benchmarked. So how do we actually benchmark or run this benchmark? Well, we scroll to the top here in our static void main. We can say var results equals benchmark runner, control dot there to add that using for using benchmark.net.running. And we'll say dot run demo. This will run this class and look for these benchmark methods. This is kind of like unit testing where we say, hey, this is a test, go ahead and run that. Well, this is a benchmark method, go ahead and run that. Now you're almost ready to run this, but there is a couple more changes. First of all, right up here we have debug mode. Let's even stretch this out a little bit. I can't. All right, because of the way that my fonts are enlarged, you can only see debug, but this is debug mode by default. We're going to change that to release mode. Now, if you're not familiar with the difference between debug mode and release mode, we run debug mode when we're using Visual Studio, when we are doing development, because it does some less efficient things in order to give us more things to look at, more debuggability. For example, normally when you're done using a variable, it goes away. But in debug mode, it's going to keep it for longer. It's not going to let the garbage collector run as often. And the reason why is because that way you can go back and inspect things later. So with the debug mode on, it's not as efficient and it's not something you'd use for production. In release mode, it takes away all that debugging stuff and only does what is most efficient. It's not as easy to debug that, but it is much more efficient, which is what you want for production. So that's why when you have a build server, your build server should always be running the release mode or building in release mode. Whereas when you're in Visual Studio, you should always be, or almost always, be running in debug mode. So in our case, we're going to use release mode because we're trying to identify the efficiency of this method. The way we identify the efficiency is if we run it the most efficient way. So therefore, release mode. Okay? And one last thing, if we hit this play button here, that's going to run and attach the debugger. Even in release mode, it's going to attach the debugger, which means it's going to have hooks into the application to listen to the various events and try and try to listen for breakpoints and so on. But we don't want that because that's going to add memory overhead and skew the tests. So we want to go to debug menu and run without debugging, or control F5. So that's what we're going to do, run without debugging. This will compile the project and it will start this process of running the benchmark. Now, what is a benchmark? I'm going to talk about this while it's running because it's going to run for a little while. A benchmark is going to identify how efficient the method is based upon running it a number of times. But when you run a system the first time, what happens is there's some startup cost. And so what this does, it's going to run it a few times, which is already done. It's going to run it a few times here as warm-ups. So it does some warm-up stuff and throws those results away. And then it does the actual testing. So in this case, we now have a completed benchmark. Now this benchmark is almost useless, but I wanted you to see it at the very beginning to see what a trimmed down, just benchmarking one method thing would look like. So first of all, it does say, okay, based upon this operating system, this version of the operating system, which is the October 2020 update, based upon this processor with these CPUs, based upon this version of .NET SDK, based upon the job running on 5.0.9 of .NET. So it's making sure that you know all of the things that went into this benchmark, because these numbers will not be the same as the numbers on your machine, and that's okay. What these numbers are not telling you is how fast this will run. These numbers tell you how fast they'll run on your machine, which isn't terribly useful if you're talking about figure out for a production environment. But that's not what benchmarking is all about. So we're going to get into how is benchmarking useful, and really when you're running one thing like this, it's not terribly useful. Okay, so we're going to see how to do comparisons. That's really where the benchmarking value comes from. But I want to see us up front how to do just the one. All right, so this is the method. Get full string. Normally, the mean or average was 3.014 US, which US is 1 microsecond, or 0.0000001 seconds. Which, yes, that's very, very, very fast. And if that went from 3 to 6, no one would notice. But this is how long our method is taking. 3 microseconds on average. There is the error rate and there is the standard deviation, which they talk about, the confidence and the deviation of all measurements. If you are a math person, this might be even more interesting to you. So by default, what happens when we run this benchmark on one method, the default benchmark, is that we're going to get how long does it take on average to run that method. 3 microseconds. Now, let's go back and look. I commented out this Memory Diagnoser. Let's uncomment that. This Memory Diagnoser is going to add even more to this benchmark. Let's run it again. Oops, can't hit the run button. If you do, what's going to happen, at least on mine, is going to say, hey, you're debugging in release mode. I want to stop doing that. Now that's because I've got the just my code turned on and some other things. It might not pop up for you, but make sure that you instead start without debugging. So what this is going to do is it's going to run those same tests the same way. It's going to do the warm up and all the rest, But now it's not only going to capture how long on average it takes to run that method, but also the memory implications for using this method. And this is going to be very important because sometimes how long it takes isn't the only piece of data. So, for instance, it took 3.049 microseconds to run this method, pretty close to the last time. But now we have Gen 0, Gen 1, and allocated. So what do these things mean? Well, it kind of explains it down here. Gen 0 is GC generated 0 collects per 1,000 operations, which if you are not a really understanding of what GC is, then that can be very, very complicated and confusing. I get that. GC stands for garbage collection. And what .NET does behind the scenes is it says, okay, instead of just cleaning up the memory every time there is a thing that's no longer used, I'll wait until it's necessary. So think of memory. Let's look at memory as this long line right here. Okay, so this is the memory that's filled, this white section. Now imagine if the letters GC, if that represented a variable that's no longer needed. Well, that goes away and those two spaces are available. But they're not really because they're kind of in the middle and they're only a certain length and so on. So what happens with garbage collection is it comes along and says, oh, hey, you know what? We can get rid of that memory usage. It removes it from memory and then it compresses down this line so that the line now has 2 less spots at the end. Therefore, we can have a new thing take up just 2 spaces or even more because we have the space for it. But that's expensive. It's not something you want to do just on a whim. Otherwise, it's going to take more memory to clean the memory than the memory you're saving, which is counterintuitive. This is why the garbage collection system is a really impressive piece of engineering that almost certainly you should not mess with. Don't just do garbage collection calls. Don't force it to run. Let it do its thing. But Gen 0, what this is the garbage collection system says, okay, I'm going to run because I need to, and I'm going to figure out all the things that are not needed anymore. I'm going to get rid of those and compress the rest. But then I'm going to mark everything that I have not gotten rid of as Gen 1, which means it survived one purge. Because the theory is that if a variable is not short-lived, meaning it's going to live for a little bit longer, then it's probably going to live for even longer. Meaning if a variable lives for a little bit, it'll probably live for longer than that. So therefore it gets moved to Gen 1. And then if needed, the garbage collector will come back to Gen 1. But it may run Gen 0 over and over and over again, only on the new allocated things, because it's moved everything else to Gen 1. Now, if it does a Gen 1 again, or Gen 0 again, it's going to move everything that's left back to Gen 1. However, if it says, you know what, I need it more, I'm going to go to Gen 1 items as well. It's going to do the same exact thing with the Gen 1 items. We're just going to look at them, and it's going to say, okay, these things I can get rid of, I'll compress the rest, I'll mark everything else as Gen 2. And it moves everything else up one level. And it does it all over again. Okay, that's a very simplified, very simple version of what the very complex garbage collection system does. So we'll probably go into it in much more depth in another video. Let me know if you want to see that video and how much it interests you down in the comments. So what this is saying is how many times does the garbage collector run for Gen 0 per 1,000 operations? Not per one operation, per 1,000 operations. And the same is true for Gen 1. So how many times the garbage collector collected per 1,000 operations? So up here, we see that we've run 2.8343 times per 1,000 operations. So the Gen 0 garbage collector has run 2.8 times every 1,000 calls. The Gen 1 garbage collector has run 0.0038 times per 1,000 calls. Obviously, we want this to run a lot less because it's the more expensive, do more call than the Gen 0 is. The Gen 0 is kind of like the easy stuff. Okay, so that tells us something, but what does it really tell us? Not a ton, because this is all information without context. And that's where we get into next, is how to give this context, because that could be fine or it could be horrific. And which it is depends on if this is a well-written method or not. And we can't really tell that on its own. So we'll get there in just a minute. This last thing right here is allocated. And allocated down here, this little legend's nice. Allocated memory per single operation, not per 1,000, per single operation, managed only, and it's inclusive. 1 kilobyte equals 1,024 bytes. So this is how much allocated memory is, or how much memory is allocated per method call. So when you call the method, it's going to put some things in memory. And if you look, let's bring this over for a minute. If you look down here, we'll see that we have this string output. We also have this integer, I. These things are stored in memory. And then this output gets sent back. So these are memory usages of our application, plus the fact that if you've watched some previous videos of mine and know about strings, like that, I had a video on, I think it's like 30 different things you need to know about strings. One of them is that they're very expensive. And this is a pretty expensive way of appending strings. So this right here tells us that we're using 23 kilobytes of memory. Again, is that good or is it bad? Well, we don't know. It's in a vacuum. We don't know if this is a good method or not. So now it's time to write another method and compare the two so we understand, are our changes making any impact? Let's do that. So now we're going to write a new method. So let's come down here. We're going to say public string get full string with string builder. All right, that's a long name, but it tells us what it's doing. So instead of doing it this way, we're going to do instead say string builder, control dot to add the using for system.text, and we'll call this output equals new. I'm going to say new string builder here. We don't have to use new string builder, but I'm going to talk about that in a little bit. So for I is less than 100, make sure that the two numbers are the same, so we're comparing apples to apples as much as possible. Output dot append I, and then down here we're going to say return output dot to string. Okay, so let's make sure that we're even bringing it back to a full string. Therefore, we are doing a full apples to apples comparison between the two different ways of doing strings. Now what we're going to do is add a benchmark at the top here. So we now have a benchmark on two different methods. So let's run this, not with the run right here. We can, actually we can't, sorry. We can do a drop down right here and say Control F5 or click this button. So let's run this again. And this time it's going to run two different methods. So found two benchmarks in total. And it's going to run both of those. Sorry, the font's a little small. I had to zoom it back a little bit in order to get all the text on the screen fully. Because these benchmarks can get a little verbose in their width of what they're showing off in order to see the that full table. So this is going to run now. It's going to run both of our methods, and it's going to show us what each of them uses for the average time run, the average memory consumed, and the garbage collections per 1,000 for both Gen 0 in Gen 1. So right now, we have our get full string normally. That takes 2.984 microseconds, which is actually getting a little better. But now notice that get full string with string builder, second line, takes 1.071 microseconds. It's almost 3 times as fast as get full string normally. We can ignore the error and standard deviation. They're going to be pretty much in line. Now, Gen 0 calls 2.8343 for the first one versus 0.1678, meaning it's not even running one full Gen 0 call per 1,000 calls of the method. That's much more memory efficient. The Gen 1 calls, there are no Gen 1 calls for the string builder version. Doesn't need them. So therefore, this is a much more efficient way of calling that same string method. Notice the end here, allocated memory, 23 kilobytes versus 1 kilobyte. You've saved a tremendous amount of memory. And this is why I say that seeing these things in a vacuum or on their own can give you some information, but doesn't give you a full picture. What it gives you is just information about the method and roughly if it's going to take up a lot of memory or not and take a lot of time or not. It's not going to tell you if it's efficient or not, because it may be efficient or it may be, like in this case, it's not. And not only that, okay, this saved us basically 3 times the time. So it's a third or 3 times as fast as the normal get full string method. But that's not the whole picture, because we're using that memory as well. That's what's it called? Memory Diagnoser as well. We also get the garbage collection information, which tells us that it's much more efficient and much more easy on our garbage collector, which means that less processing time will be taken, but it's also much better for our memory. So this information can make a lot of impact in your decision making about which way you go with a certain method. If your tweaks make sense or if they actually negatively impact your application. Again, this is a comparison on my machine. So right now, here are the stats in which this will be the case, these numbers. But does it really matter? Because if this is the difference, 23 kilobytes versus 1 kilobyte, that's going to be the same or similar on other machines. The amount of garbage collection, that will be different, but this ratio probably won't be. It'll be pretty close to the same. So the ratio is what's important. But what we don't have here is a good ratio comparison. So let's add that. So in this benchmark right here, this is the normal version. We can say, hey, this is the version we have in our code right now. We're thinking about adding this. Will it make an impact? Well, we already know it will, but let's do a comparison more easily. We're going to say in here, baseline equals true. And what this does is it says, okay, this is the method to base everything against. And maybe you have 3 different versions of this or 4 different versions, but this is the one that you want to do the comparison against. Now, I'm not going to add a lot of methods here. Let's run this right away. We'll talk more about this. But I'm not going to add a lot of methods here to test against, like doing a string interpolation and other things, because that's not really the point of comparing all these different ones. You can do that if you wanted to test different tweaks, but the more methods you add, the longer this takes. And this is going to get to be a little bit longer than I want to show on video. So I don't want to keep adding to it and make it too long. So, but what this is going to do now is it's going to run both of those like before, but this time it's going to say, okay, the gold standard, the one we're going to compare against is that first one, the normal way of doing things. So now we have this new column here called ratio. And the ratio says, hey, get full string normally, that's the benchmark, or that's the default. Therefore, this is the baseline. Sorry, that's the baseline. Therefore, that's 1.0. And this down here, in comparison to the baseline, this is 0.36. Anything less than 1 means it's better. Anything more than 1 means it's less than or not as good as the benchmark baseline. So with that, we now see that this is really about 3 times, almost 3 times as good as the normal version. That's what it's doing, is just taking the mean and saying, hey, compare that to this. So even that ratio, just note that it's not taking into account things like memory allocation, because obviously the string builder version is about 23 times as good. So this would be a ratio of 1 to 0.03 roughly, or I'm sorry, 0.25-ish. So that would be a different ratio. But this ratio right here at least tells us, hey, compare these two numbers. Because if it's close, that's going to tell you that. And if you have 5 or 6 different versions, at a glance, you can see, hey, which is the smallest number? That's the one I want to look at most intently. So that is the comparison using benchmark.net for 2 methods. But we're not done yet, because right now we're doing a comparison on .NET 5, specifically .NET 5.0.9. But what if you want to compare this to other versions of .NET? Well, fortunately, we can run our console app on .NET Framework and other platforms as well. Let's do that. So let's do a comparison. We're going to take off this baseline here, but we're going to add it in a different spot. What I'm going to do now is I'm going to say above Memory Diagnoser, I'm going to say this is a simple job with a runtime moniker. And that runtime moniker is going to be whoops, that's a capital R right there. Control dot here to add using benchmark.net.jobs. And we're going to say, let's do net 4.8. This is where a little confusion is going to come in. If you haven't watched my video on dev questions about the different versions of .NET, I would highly encourage you to check that out. Otherwise, this might be even more confusing. But what that's going to do is we're going to compare .NET Framework 4.8. Let's do a copy here to .NET 5.0. Now you have to have the .NET versions installed on your machine, the SDK, which you can get from Microsoft if you don't have them installed. But I have both of these, .NET 4.8 and .NET 5, both installed on my, let's do .NET, sorry, I was having probably .NET 4.8. Let's do .NET 4.7.2. So I don't think I have .NET 4.8 installed. I have 4.7.2 installed though. Sorry. So I have both of these installed. So let's compare .NET 4.7.2 to .NET 5. And again, if you haven't watched that video on dev questions, I'd highly encourage it. But these are not that close. It may look like, oh, the version difference is just a little bit. No, this is .NET Framework. This is .NET Core. That is about 4 years difference in the comparison, maybe 5. But this is .NET Framework 4.7.2. This is .NET Core, which has now been renamed .NET 5. So it's a big difference in comparison. Now, we also want to say that .NET 4.7 is the benchmark. So let's put a comma after here and say benchmark, or I'm sorry, baseline. I keep saying benchmark. Baseline is true. And this will make the .NET 4.7 version of the method calls the baseline. So with that, we're almost done, but we're not done yet. We do have to modify our project, because right now our project builds for .NET 5, which is .NET Core, .NET 5. We don't build for .NET Framework 4.7.2. We can change that by right-clicking on our benchmark project or benchmarker project and saying Edit Project File. This opens up the project file, which is very small now, which is very fortunate. We don't have to go through a lot of different flags in here, but in here, we're going to change this from Target Framework to Target Frameworks, plural, both the beginning and the end. And now, after .NET 5.0, we can put a semicolon and say .NET 4.7.2, which is .NET Framework 4.7.2, or 4.7.2. So this is going to double compile our application, and it's going to create the ability to benchmark both of those. Now, we got a bunch of warnings and errors at the top here. Don't worry about those. The first one says, hey, one or more projects have changed. We've got to go ahead and reload the project. Cool. The second one is that the release any CPU configuration is empty. We'll need to do a Nuget restore. Okay, not a problem. So let's hit reload project. Let's do a rebuild solution, not build solution, rebuild solution. There we go. And we can enable IntelliCode, that's fine. We can close out of this error message. We can close out of the IntelliCode. So what does the rebuild project do? What it does, it clears everything out and it starts over. So when you build things, it tries to do shortcuts in order to make the build time faster. With a rebuild, it's going to clean out those folders, and then it's going to build everything from the ground up again. So with that, now let's go to Start Without Debugging. And it's going to run our benchmarks again. It found 4 benchmarks this time, not 2. Why 4? Well, it's going to run both methods in .NET Framework 4.7.2, and it's going to run both methods again in .NET 5. So this is going to take twice as long as not quite twice as long, but it's going to take more time than it has been taking before. In fact, it might actually be a little bit longer because of the .NET Framework. Now, some of you have heard me talk about .NET Framework versus .NET Core. This is going to highlight one of the big deals about why it's very important to move to .NET Core, or why it's very beneficial, I guess is a better way of saying that. It's very, very beneficial to move to .NET Core. Our code is not going to change between .NET Framework and .NET Core. Our actual C# code is not going to change, but we are going to see a difference in how fast that code runs and how efficient that code is. So I want you to notice this when we look at the benchmarks, because it's not just about whether we have our normal version versus a string builder. We're going to see that not only is our, let's maximize this here, not only is our normal versus our string builder more efficient, but .NET Core is as well. So this is notice that the ratio is going to be for .NET Core, or .NET Framework versus .NET Core. So the top line here, the top 2 lines are get full string normally. The top line is .NET 5. The second line is .NET Framework 4.7.2. So the average is 3 microseconds for .NET 5 normally. For .NET Framework, the average is 7.4 microseconds, double the time. Now, look at the Gen 0. We're just going to look at this first 2 for a minute. Gen 0 for .NET 5 is 2.8 calls per 1,000. For .NET Framework, it's 3.8, almost 3.9 calls per 1,000. For Gen 1, it's 0.0038 versus 0.0076. So it's much more efficient to run the same method in .NET 5 versus .NET Framework, even though it's an inefficient method. Now look at the allocation. The allocation is actually a little better, 1 kilobyte different for .NET Core versus .NET Framework. Let's go down to the string builder. So .NET 5, we can see the 1 microsecond, but then notice that compare that with .NET Framework, it's 5 microseconds. So I want you to do a quick comparison here. Look at the string builder version in .NET Framework versus the regular version in .NET 5. The string builder version in .NET Framework is 5.8 microseconds. The regular version in .NET Core 5 is 3 microseconds. It's actually almost twice as fast to run the get full string normally in .NET 5 versus the string builder version in .NET Framework. So just by upgrading to .NET 5, you can actually have even poor methods outperform optimized methods in .NET Framework. All right, so some cool comparison we can see here. But also notice that for the string builder method, notice that the ratio framework versus core, it's 0.18 in .NET 5. It's improved by almost over 5 times in performance. Yes, the memory usage for the .NET Framework version is more efficient than even the .NET 5 regular, but it's 4 kilobytes versus 1 kilobyte in .NET 5. So it's 3 or 4 times more efficient memory-wise for .NET 5 with a string builder versus .NET Framework 4.7.2. So this gives us a lot more insight into how our application is going to execute. Again, we can't look at it just and say, okay, this method is going to take 1 microsecond. That's on this machine, okay? That's with these things being true. But what we can say is that the string builder is more efficient than normally, and that the .NET 5 version of string builder is much more efficient than anything else, whether it's the .NET Framework version of string builder or the even .NET 5 version of normally. So we can see that upgrading our code to .NET 5 will have a significant performance boost over just using it in .NET Framework, both in terms of memory allocation and as far as speed. It's almost a 6 times speed increase. It's over 5 times the speed increase to just upgrade to .NET 5 with this method. But not only that, we also see that it's better than this other method, even if it is in .NET 5. So that gives us a lot of different comparison tools to look at. And yes, you won't want to compare everything all at once, because most likely you're going to be looking at either, is the upgrade worth it? Upgrade to .NET Core? Well, in that case, you wouldn't need to have these two methods being compared. You can compare just one of them to the two frameworks. Or you'd be looking at, is this version of the method better than the other version? In which case, you wouldn't need the different frameworks. But I want you to see all of that all at once, because I think it gives you a good perspective on how benchmarking works, on why looking at different ways of doing a method are important. Because, I mean, this method is more efficient than this method, even if you're in the same version .NET 5, but also looking at why it's important to upgrade to .NET Core, because even just doing from this efficient method from .NET Framework to .NET Core, you're going to be over 5 times as fast. Again, your mileage may vary. So you'd have to benchmark your own code and go, oh, hey, we can save, 40% of our time, or we can save 30% of our memory usage. Whatever it is, those will probably be better than that. But you're going to see what exactly is you're going to save by going to it. And that can give you the case for why a change in method is important. Like, hey, I know it's going to take some time to do the testing and make sure this works and all the rest. But I think it's worth it because it's going to save us a bunch of memory allocation. Okay, so we can really reduce how much memory is being used on the server, or it can tell us, hey, you know what? We need a bump from .NET Framework to .NET 5. I know that it seems like nothing's going to happen, but it's going to be a real big memory difference. It's going to be a huge speed improvement, and really the code doesn't have to change that much. Now, of course, yes, the code's going to change some because you have to change dependencies and all the rest. But with this tool, you can really give some numbers behind your ideas. But not only that, it can give you a good idea of, is a refactor even valuable? So maybe you say, hey, you know what? Instead of doing, let's close this out. We've seen these numbers enough. Instead of doing this, maybe we're doing this right now. We'll say, hey, you know what? Instead of doing that, let's do something like this, where we come over here and we say output equals, string interpolation. Then we'll say output, and then we'll say I. Because that's more readable. It's not, but maybe we think it is. Okay. Well, you could benchmark these two different ways and go, we're not saving anything. We're maybe even hurting ourselves a little bit. That gives you a better perspective on that. So just being able to do those two different things will give you an idea of, is this change valuable from an application standpoint? Maybe you run the method and go, hey, I noticed this is using an awful lot of memory. What can I do to reduce this memory usage? Maybe make some tweaks to it, do a second method, do the comparison, go, oh, that didn't change the memory allocation at all. Or that really reduced the memory allocation. It may be a little bit more funky looking, but it's going to be more efficient for our memory. This is a valuable fix. Again, you can take hard numbers to your boss and say, I have benchmarked this, and this is a 5 times memory improvement. Bosses love to hear things like that, especially if you can show that memory is not going from 4 kilobytes to 1 kilobyte, but more like 24 kilobytes to 1 kilobyte. Because then you're like, wow, that's an actual impact on our system. So with that, you can say, okay, now we use this for 1 million customers a day, or whatever your numbers are, probably not 1 million a day, but whatever it is, you can do some math and say, it looks like we'll probably save about this much memory. And you can know that before you put it into production. And then you can watch the actual numbers, verify or validate what you're seeing. Now, make sure you check your estimates and don't overestimate. But based upon your numbers here, you have at least a start of good information about what kind of memory pressures you can relieve, or what kind of garbage collection you can reduce, and so on. So that's benchmark.net. There's a lot of things you can do that. If you want more information on benchmark.net, you can go to benchmark.net.org, which is confusing. So let's look at it real quick here. I'm going to zoom in here. So benchmark.net.org. That's the URL you can go to. I'll link that down in the description. But at this place, you can see more information about it. You can even see how to run these charts. I didn't show this off, but that's really just one extra line. Let's see right here, our plot exporter. There you go. And with that, you get these nice charts that you can play around with and see your benchmarks in more living color. Okay. And not only that, there's also more docs in here about, let's go to the articles right here. There's more documentation on the features, statistics, disassembler, and so on. You can go in a lot more detail about how this works, what you can do to tweak it, even some samples for a number of different things on how to get these things to work. So benchmark.net.org is the place to go to get all your information about benchmark.net. It's a great tool to use, to learn, and to take advantage of. One quick note though, before I go, just be careful, because when you're benchmarking, it's running your application a lot, or running your methods a lot. So when it does that, make sure that you are prepared for it. For example, if I had in here database code, make sure your database is ready to handle that many inserts or reads or whatever it's going to do, and that's not going to mess up your database. Don't do it against a production database, or if you do, make sure you can roll back or have good backups. And the same thing with API. If you're going to call an API that rapidly, make sure that you can call it that rapidly. You're not going to run into things like getting locked out because of too many calls and so on. So be very careful not to make this a system stress test that you don't want to have run. But do run your code against this, try different things, test out various pieces of your application, usually the logic pieces, the pieces where they're running on their own, not pieces that are requiring UI interaction and things like that. That's something different. But this is for the actual C# code itself that's running on its own. You can test it against each other and see if you can come up with a more efficient version or how a change to, let's say, .NET 5 versus .NET Framework 4.7.2 might interact. All right, so that is the demo. I do want to move this over. So I'm going to select demo, hit Control Dot, and say I want to move type to demo.cs. There we go. So now it's much more in line with what I would like to see from a project, which is that every class has its own file. So there we go. I'll give this source code to you. They'll be linked down in the description. You can get fill out your email address, and I will email it to you right away. And if you have thoughts on benchmark.net, leave them down in the comments. If you have questions about it, if you want to see more of that garbage collector, leave those comments down in the comments below this video as well. I'd love to hear your thoughts. Thanks for watching, and as always, I am Tim Corey.